Okay, guys, this is section 7.4, properties of logs. So we talked about how logs, we can think of it kind of like the inverse of exponential growth. And I guess let me start off by writing it like that. Exponential growth, we've seen y equals a b to the x, which we can think of it like that when a is 1. So flipping that around as a log, we get this guy. That's the log form, remember? And then the exponent form of that would be b to the x equals y. Okay, so this is just a reminder from how those two things go hand in hand, how you have log form and exponent form there. Good. Now, like the notes say, there are several properties of logs that can help us solve some bigger equations and expressions. The first one here is the product property. Okay, and it's called product because it deals with multiplication. Just like everything else in math, when you hear product, you're thinking multiply. When you have a log with two things being multiplied, and that's what I'm circling here, this m and this n, we can actually break that up into two separate logarithms like this, log m plus log n. So you're taking two things that are being multiplied and you're breaking them up with addition. Conversely, you can do the other way around. So you can have two logs, for instance, that are separated by addition, and you can combine them into one with multiplication. Okay, so good job on that. Let's take a look at first example here. Log 2x plus log base 2y. Well, one of the key things is they have to have the same base. This log here is base 2. So we can combine this into one log base 2. Since they're separated by addition, I can go ahead and make that log base 2 of x times y. Okay, so this is me consolidating it down into 1. The next one, pretty similar. The base here this time is 10. Remember, when there is no number down here, we assume it to be a base 10. Jot that down. So let's go ahead and combine this into one log of base 10. And since we have addition here, that means we're going to combine the 15 and the 3x by multiplication. So it's log 15 3x. And that will actually simplify a little bit further to log 45x. Okay. Next one, log 100 plus log base 6 of 12x. What do you guys notice here? Maybe you look at this for a second and realize that this one is in base 10. This one is in base 6. In a situation like this, you can't combine. Remember, I said a little bit ago that it has to have the same base. Obviously, this doesn't, so we cannot simplify it. Okay. And the next one, log base 3, 9x. This one goes the other way now. I'm going to take my single log, and I'm going to break it up into two logs, both of which are going to be base 3, and they're going to be separated by addition. They are separated by addition because I am multiplying the 9 and the x. Those are the two things that I'm going to break apart. The 9 is going to go right here with the first log, and my x is going to go down here with the second one. So it's log base 3 9 plus log base 3 x. Now some of you guys actually might notice something about the log base 3 9. That's actually going to simplify. Okay, if we think about this log, if I visualize it from log form and I flip that around to exponent form, maybe that helps you see what I'm talking about. 3 to what power takes us to 9? And it's not 3. Everyone wants to do 3 times 3. We're doing with exponents here. So it's 3 to the second power here. So since x equals 2, what that really is saying, guys, is that log base 3 9, that's straight up equal to 2. So this expression can be simplified like that. 2 plus log base 3 of x. Okay. Next property is the quotient property. It's actually the same idea, except instead of multiplying, like the product property, we are now going to divide, right? When you hear quotient in math world, you think division. So if you look over at the model here, whenever you have two things that are being separated by division, this m and n, we can break up them into two separate logs separated by subtraction. That's the only difference. And then conversely, we can go the other way. If we have two logs separated by subtraction, we can throw them into one log with division. So check out this first one. Log base 432 minus log base 4, 2. Let's go ahead and combine that into 1. It'll be log base 4. The numerator is always the first number. In this case, that's 32. The denominator will be my second one, 2. So it's log base 4, 32 over 2. What is 32 over 2? That becomes 16. Now maybe some of you are looking at that and you recognize, oh, I know what that is. Log base 4 is 16. That's going to actually simplify much easier down to 2. Because 4 to the second power equals 16. Okay. Next one, another log or another problem with two logs separated by subtraction. So let's go ahead and combine it into one log. This time we are in base 3. And we're going to have 36 divided by 4. Well, 36 over 4 is going to simplify to 9. So now we've got log base 3, 9. That should look familiar. We've seen that once already on this page. When you have log base 3, 9, that's equal to 2. We had that back up there in the top part. So this actually becomes the number 2. Guys, the reason we do this, if you look back at the beginning of that problem I just did, log base 336, that's nothing in particular, right? Like if I was trying to do 3 to the x equals 36, I'd have a real tough time trying to nail down what that x value is. Same thing with the other half of that, right? 3 to the x equals 4. Those two numbers by themselves are going to be some crazy decimals. I'm going to have a tough time trying to find that out. But fortunately, our properties of logs, when you combine them together, give us this nice log base 3 of 9 right here. That's a lot easier to work with. So again, that's an advantage of these properties. The last one on this page, log 4x over y. This time we are in base 10, and this time I'm going to split it up. So I have two different logs, and it's going to be separated by subtraction. Subtraction because we are dividing. I have 4x on top, so that's going to go first. And I have y on bottom, so that's going to go second. So I get log 4x minus log y. Good. Now if you catch this, you might notice that the 4 and x actually, that deals with the product property, like we just did above. I can actually break this down even further and make this log 4 plus log x minus log y. Cool. All right. Feeling good about that so far? All right, let's look in the next page. And this one is called the power property, the third of our properties today. And this deals with exponents, okay? With exponents, obviously power makes us think exponents. Here's what I want you to see. Look at this model here, okay? Log base b, m to the n. That is equivalent to n log base b of m. So what's that saying here? Well, if you look at the first half of this equation, n is your exponent. In the second half of the equation, n is in front of the log. What happens when you have logs is that exponents, and this is kind of the note I'm going to make, they go from exponent land, yeah, that's right, exponent land, down to the mainland, and vice versa. You could go from the mainland, if it's in front of a log, up to exponent land. All right, and that's exactly what this property is showing us here, which is kind of cool. Check out the first example. We have 2, log base 5 is 7. So my number in front here, that 2, that can go up to exponent land, and that expression is equivalent to this, log base 5 of 7 squared, which is log base 5 of 49. Okay. Next example, 4 log x. I have a number in front of the log. That 4 can become my exponent. So this becomes log x to the 4th. And the next one here, now I have an exponent. I want to take that exponent And instead of leaving it up top, I'm going to move it now down in front. So this expression becomes 5 times log base 3x. Okay. And the last one, I have log 100 times x to the 6th. Notice here, guys, product property. That's the first thing I want to do is split up this 100 and this x to the 6th. So log 100 plus log x to the 6th. Okay. Again, I just separated because they're being multiplied up here. So I separated with addition into two separate logs. That is advantageous for us because hopefully you notice log 100. The base 10 gets you to 100. That's going to simplify to just 2. Now the other piece of this, the log x to the 6th, let's use our power property and bring that 6 down in front. We get 6 times log x. Now a lot of people at this point would want to say, oh, I can combine the 2 and the 6, right? And make this 8 log x. Ta-da! No, you can't do that. 2 and the 6 are in separate terms. 6 is attached to this log x thing right here. We cannot combine it, okay? That would be like saying, oh, I can combine 2 plus 6x and call it 8x, right? Ta-da! No, can't do that. You guys know that. So we are done at this point. It is 2 plus 6 times log x, okay? The last part here, it's called the change of base formula. And for this, we're going to need a calculator. And this really, guys, I'll make a note of this, is the shortcut to solving logs. Okay, I'm going to try and go through this a little quick here. I'm running out of time. The first one, if you look at it, it's log base 536. And if I flip that around into exponent form, okay, let's visualize that for a second. 5 to the x equals 36. Okay, I don't know what power of 5 is going to take me to 36. So I don't know what x is at this point. It's kind of tough for me to figure that out. One thing you can do is you can take the log of both sides. Log 5 to the x equals log 36. Okay, so notice what we did here. Take the log of both sides. And what that does for us here, if you catch this, look at the left side. We have log 5 to the x. Think back to my power properties from above. What can I do with that exponent now? I can take that x and move it down in front. X times log 5 equals log 36. So hopefully you can see what we just did. We just took an exponent variable. We didn't know what x was, and it was in the exponent. Made it pretty tough to find. Okay? Everyone wants to square root it, but you can't square root that here. What we needed to do was, same thing up here. We needed to go from exponent land down to the mainland. That's exactly what I did. I brought that x down in front of the log 5. Now, like any other expression, if I'm solving for x, to get it by itself here, I just want to do log 36 divided by log 5. I'm just going to divide, right? Since I have x times something, to get that x by itself, I just need to divide. And you can do that on your calculator. You got to use the log button, okay, which we've talked about that in class where you can find it. When you type this into your calculator, make sure you put parentheses around the numerator. A lot of people, if you don't, it's a mistake a lot of people make. If you don't, it's going to screw it up. You're going to get a goofy answer. But when you type that in, your answer should come out to 2.227. Now, look at the cheat formula here. What I can jump to is just this. Look at my original expression. It was log base 536. I can jump to log of 36 divided by log of 5. You can plug those things right in there, and that'll give you your answer. So let me do it on the next example here. X equals log of 24 over log of 8. I'm simply plugging in to the appropriate spots. Log of 24 over log of 8, when you type that in, should be 1.5283. Okay. We'll keep doing some practice like this, but this is the shortcut that I'm talking about to solving logs. Okay. Hopefully that makes sense, and we'll wrap it up for now. Okay.